Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter is how to select your continuous improvement projects. Now, this could have been called how to select your Six Sigma projects, but I've said continuous improvement projects really because the methods I'm going to describe aren't necessarily about Six Sigma projects. They could be, but actually all your projects should probably be selected using one or all three of these methods that I'm about to describe. So let's have a look at this. So how to select CI projects. Now, one of them is a Six Sigma method, one of them is a lean method, one of them is probably maybe just common sense. But let's take a look at the three methods that I'm gonna recommend to you. So the first one is probably the formal, bureaucratic Six Sigma way of doing it, and it's to do this. It's to go and talk to your customers, collect the voice of the customer. What is it that the customers want from your product and your service? And it will be both of those things, by the way. Some of the things they will name could be things about the performance of your product. So they want it to last a long time, for example. But it could also be the quality of your service. So they want it to last a long time. They want it to be highly reliable. They don't want little technical little faults while they're using it. So that's more to do, of course, with the way that you manufacture it as opposed to the way you design it. So if you go and collect the voice of the customer, this could be about design, this could be about process. So the voice of the customer, and then you turn the voice of the customer into something which is measurable, something which is critical to quality. Okay, known as CTQ, something which is measurable. So just to put something up here, this needs to be, by the way, prioritized. So you get a prioritized voice of the customer. Then what you get is a prioritized list of what's critical to quality. Now, what are CTQs? Typically, CTQs normally is measurable. It's something which is measurable. So as an example, the voice of the customer is normally very non-technical. It'll just say things like, I want the product to last a long time. I want the product to be reliable, that type of thing. What you're then going to do is to turn those phrases into measurable things. So if you say, customer says, I want the product to last a long time, you might decide when you convert that into a CTQ, that means it lasts at least 5 years. And then you've got something that's measurable. You can measure your product and you say, well, is my product capable of lasting for 5 years before you've got to throw it in the bin and start again? And of course, now what you can do is, once it's measurable, you can then ask the question, how are we doing? And of course, if anywhere there is a shortfall on your CTQs, maybe that's a project. Now, doing it that way, the great thing about doing it that way, this can pick out projects for design for Six Sigma. This can tell your designers what to do. This works for design for Six Sigma when you're designing new products and services. But then it also tells you for the services and products you have in play at the moment, in production at the moment, what things should you work on to improve? So, voice the customer, CTQs, look for the shortfall, do a project. Very straightforward. The next one down is the lean tool. You could do a value stream map, sometimes also referred to as a big picture map. Again, this is all about the customer. You are trying to map the customer experience. So if you take a look at this graphic, here is a little example of a big picture map. What the big picture map is showing you, what it's measuring, is the customer experience. And what it's designed to map is one order from a customer. So over in the top right hand corner here, we have a box which is the customer. The customer places an order, and then every box subsequent to that is the activity that takes place to convert the order from an order into goods. So at the top you start to see the planning and the purchasing process. So material gets bought and the job appears on a production plan somewhere. Because the order for material goes out to a supplier over here on the left hand side. Then the material arrives. Then the bottom boxes are the conversion process, and eventually the goods are complete and the order goes back to the customer. So it's another version of the voice of the customer in a way. It's almost the experience of the customer. And then what you're doing is you are looking for points where flow is interrupted. Any point where flow is interrupted. And of course that is what the 7 wastes are about. The 7 wastes all measure interruptions in flow. And that's the only thing they're doing. Nothing else. I'm going to apply it to people. It's the flow of goods through the factory. Now, one of the 7 wastes, of course, when you do the big picture map, is defects. Defects are indicated on the big picture map. The opposing arrows that you see, that's rework. The big Q that you see, that's a quality point. So you will typically see defects on the big picture map. If you see defects on a big picture map, then potentially that's a project. And finally, of course, what you could do is just go and look. I'm going to call it the cost of poor quality. I'm actually going to say the cost of quality. So I'm going to miss out poor, I think, because I prefer that phrase. The way to do this is to just look at the cost of quality and then to go fix the biggest cost of quality and transform your cost of quality, because your cost of quality typically is going to be split into 3. You are going to get the REEs, costs of rejects, recalls, repairs, etc. Okay, so let's put a colour in for this. So we'll say maybe the cost of the REEs currently looks like that. Then you're going to get appraisal costs. So here are the appraisal costs. And finally, you're going to get the prevention costs, doing a bit of fire prevention instead of firefighting. So here's the firefighting cost. We want to see how much money are we spending on prevention. So looking at the cost of quality. And then of course, you're not going to get rid of all of this, but you're going to tackle the biggest. So what you're going to do now, again, you're looking at defects typically. You're looking at errors. You're going to take the biggest, and that typically is going to be a project. And that really is how you select the projects. It may be nice to do it the correct way, because obviously this is how you should start off the whole process of designing a new product or service right from the beginning. And if you get a prioritised list of the customer, you will please the customer, and then you'll just get lots and lots of really happy customers, and you'll make piles of cash. So these are different ways of doing it. This is also the lean way, also a great way to do it, because on the big picture map there are lean projects here. This is all about setting up pull systems and putting in stock control systems and better planning systems and getting rid of setup time and all sorts of great lean projects. So there's lots to be gained from doing this as well as doing this. But a nice simple way to start is to look at the cost of quality. Where's the money for? Is it in prevention or is it in firefighting? And of course what you're going to try and do is reverse the shape of that diagram, and that's the way to pick projects. And the one last thing to say about the Six Sigma project that's really important, it should be a technical problem. It should be a technical problem. The Six Sigma toolkit is world class technical problem solving. That's what it's capable of. World class technical problem solving. Six Sigma was invented to do that. That was what Motorola needed, so that was what they invented. Six Sigma is world class technical problem solving. So go and find your technical problems, then use Six Sigma to smash those problems out of the water and make shed loads of money. Don't go focus Six Sigma in offices and things like that where you know, maybe some simple lean tools and some common sense almost will fix it. Six Sigma is a fantastic world-class technical problem solving toolkit. If you want my opinion, you can solve anything with that toolkit technically. I'm happy to come and solve anyone's problem, even though I've never seen your process before. World-class technical problem solving. If you'd like to know more about any of the concepts covered in this video, or any of the other concepts covered in my other tutorial videos, then here's my latest book, Drink Tea and Read the Paper. Covers everything you need to know about how to make sure that Six Sigma becomes world-class engineering in your company.